Our next section is going to cover operations on radicals. And in math, when we talk about operations, you want to think like addition, subtraction, multiplication, division, and potentially exponents or square roots, okay? So operations with radicals, and a few definitions before we get started, some things I want to remind you of. First, the number under the radical symbol, that symbol, is called the radicand. Remember that, because we're going to talk about a radicand bunch in this worksheet. Next, the square root of a number is one of two identical factors of that number. The cube root of a number is one of three identical factors of that number. And finally, the nth root of a number is one of n identical factors of that number. And that idea kind of leads me to this other definition that's not officially on this worksheet. If we had something like this, a number inside that little elbow part of the radical symbol, that n is called the index. And this is the number of identical factors needed to simplify something outside the radical symbol. Now, we always put it in there if we have some index bigger than 2. So if we have an index of 3, that would be a cube root. If we have an index of 4, that would be a 4th root. If we had an index of 8, that would be an 8th root. And that number, again, tells us how many identical factors we would need to pull something out of the radical. The only time we don't put a number there is if we're dealing with a square root. So when n is 2, we just write it like this. We just don't put the 2 there. It's understood. Okay, so kind of keep that idea of index and radicand in mind because we're going to talk about that quite a lot. Okay, so for this video, we're going to focus on topic 1, which is adding and subtracting radical expressions. And we have another definition. So 2 or more radical expressions that have the same radicand and index are called like radicals. Okay, so this is very similar to like terms. Okay, so very similar to like terms. Back when we were talking about just our introduction to algebra and we were learning about like terms, we found out that like terms were terms that had matching variable parts. Like radicals have matching radical parts. So this means we have matching radical parts. So something that would be considered like radicals would be the square root of 5 and 4 square root 5. The radical part matches. And even though the radical is definitely a number, you can treat it like a variable. Again, I can't say this enough. It is not a variable, but you can treat it like a variable. If I were to combine 1 square root 5 and 4 square root 5, I could do that because I would have, if I was adding, I would have 5 square roots of 5. So even though the square root of 5 is for sure a number, you treat it like a variable while you're playing around with these. A non-example, that would be something that kind of looks like radicals maybe, but is not, would be something like if we had the square root of 5 and the cube root of 5. So in this case, the radicands match, they're the same, but the index is not. And both of those pieces have to match to have what's called like radicals, okay? And if we have like radicals, we can very easily add and subtract them. So when we're adding and subtracting radical expressions, we're looking for those like radicals that we can combine. So let's look at the steps. Remember, sometimes when we write steps out in words, they don't totally make sense until you see it in practice. So just kind of be patient with this next little part. We'll practice very, very soon. So steps for adding and subtracting like radicals. If necessary, simplify the radicals so that they have the same index and radicand. So sometimes you'll be presented with 2 or 3 radicals that don't look like they're like radicals, but if you simplify them, sometimes they simplify down to where they really truly are like radicals. So the first thing you want to do is look to see if you can simplify and then worry about the like radical part. Once you have like radicals, you then add or subtract the non-radical expressions and leave the radical portion unchanged. So when you have these radical expressions, again, they are not variables, they are numbers, okay? But we treat them like variables. So if there's a coefficient on a radical, you can add or subtract those coefficients, and then you just leave the radical part alone, okay? And then here's what I've kind of been saying. It's helpful to treat the radical part of these expressions like a variable. I cannot emphasize this enough. The radical expressions are not variables necessarily. They're numbers for the most part, but we treat them like variables. They work the same way as far as combining like terms. They work like that, even though it's just a number. And then finally, if you have unlike radicals, they cannot be combined, okay? So remember, These radical expressions for us are generally going to be numbers, but we treat them like variables, and this is just like combining like terms, okay? So let's look at example one. Example one says add or subtract is indicated, and we have 4 parts that we can practice with. So for part A, we have 7 square root 3 minus 9 square root 3. The like radical part is the square root of 3. And then we have these, I'm going to put in quotations, we have these like coefficient parts. Well, that's the 7 and negative 9. So what we do is we combine those coefficient looking parts. So we combine this 7 and the minus 9, and then we just tack on the square root of 3. So 7 minus 9 is negative 2, and then I just leave the square root of 3. So for just a brief moment, we're going to jump over to the calculator. So write this down, pause the video if you need to. What we're going to do is we're going to take 7 square root 3, subtract 9 square root 3, and verify that that equals the same thing as negative 2 square root 3. So let's go over to the calculator. Hopefully I have it up. I think I do. I do. Okay, so remember we had 7 times the square root of 3. And then we want to go outside the radical. So I type in 7 square root 3, and then I'm going to move over by using the right arrow. And it takes me outside the radical. And then I'm going to subtract 9 square root of 3. And when we do that, we get negative 3.464 and a bunch of decimal places after that. Let's double check and make sure negative 2 times the square root of 3 gives us exactly the same thing. And that can prove to us that what we've done is valid. So we have negative 2 times the square root of 3. And there you have it. They are exactly the same. So that first expression, 7 square root 3 minus 9 square root 3, truly is equivalent to negative 2 square root 3. There we go. All right, so we are good to go here. Now for part B, it looks a little wacky. We have 14 cube root of 15x plus 7 cube root of 15x. Do we have like radicals? And the answer to that would be absolutely we do. The like radical portion is the cube root of 15x. So then we want to look to see if those cube root of 15x parts have constant factors, we'll call it, okay? Think of it as it works the same as a coefficient, but it really is just a constant factor. So we have this 14 plus this 7. So that means I've got 14 cube roots of 15x, and I've got 7 more cube roots of 15x. So that means total I have 14 plus 7, which is 21 cube roots of 15x. So there you have it. It's really that simple. You just treat the cube root of 15x like a variable. You add the coefficient parts, and then you just tack on that like radical part. All right, part C, we have the square root of 5 minus 12 square root of 20. Right off the bat, you're going to be like, nope, they're not like radicals. But remember up here, when we were talking about the steps, the very first step says sometimes it's necessary to simplify your radicals first, and then they maybe don't look like they're like radicals, but after you simplify, you see, oh, okay, they really were. So let's see if that is the case for part C. Let me scroll down here. Okay, so for part C, we have the square root of 5. That cannot be simplified. Remember, in order to simplify square root, we want to divide out any perfect square factors and then simplify those. Since 5 is prime, the only square root factor it has is 1, but we don't count that. So we're done with 5. Let's look at 20. So we have the square root of 20. Well, I know that 20 is the same as 4 times 5, and I know that 20 is the 4 times 5, and that 4 is a perfect square. So I can come up here and I can say, okay, I have my square root of 5 minus 12, and then I have the square root of 4 times 5. Well, remember, we can take a radical, a single radical, and we can break it up into the product of 2 or more radicals. That's that product rule for square roots. So I've got my square root of 5 minus 12 times the square root of 4 times the square root of 5, and the square root of 4 is just 2. Right? That's one of those 2 identical factors of 4. So I get the square root of 5 minus 12 times 2 times the square root of 5. So that's the square root of 5 minus, well, 12 times 2 is 24, square root of 5. Now we have like radicals. So it just took a little bit of simplifying, right? Once we simplified the square root of 20, we realized that really simplifies down to just a square root of 5 with this constant factor out front. We can now combine. So what you may not notice here is on the square root of 5, it has a constant factor of 1. So I want to take that 1 and I want to subtract the 24. Well, 1 minus 24 is negative 23 square root 5. And because we're dealing with strictly numbers, we can check this on the calculator. So let me get my paper version so I don't forget my numbers. So pause this, make sure you get everything written down, and then we can meet together at the calculator. So we started out with just a square root of 5. From that, we wanted to subtract 12 times the square root of 20. Well, when we do that on the, oh, whoops. Was anybody going to yell at me? Were you all yelling at home? We have the square root of 5. We want to leave the radical. So hit the right arrow and then subtract 12 times the square root of 20. And that gives us negative 51.429 and a bunch of decimal places after that. What we want to compare that to is negative 23 times the square root of 5. Let's see if we get the same thing. And we do. So we can see that that original expression, square root of 5 minus 12 square root 20, is exactly the same thing as negative 23 square root of 5. So hopefully that's helping you understand that what we're doing is valid, okay? And you can always check if you're dealing with strictly numbers. If you have variables thrown in there, you can't really check it on your calculator, but otherwise with strictly numbers, you could. All right, finally, let's look at part D. So part D, we have 11 square root 8x plus 3 square root 18x. Well, right off the bat, they don't look like they're like radicals, but let's see if they simplify down. So let's look at 8, and then we'll look at 18 separate. Well, 8 is the same as 4 times 2. 4 is the same as 2 times 2. And remember, when we're dealing with a square root, we're looking for two identical factors. I have a pair of two identical 2's right here. So that tells me one 2 can come outside the radical. The other 2 has to stay inside the radical. So this becomes, right here, this is going to become 11 times the 2 that comes outside the radical. And then underneath the radical, this 2 right here and the x have to stay. That x and the 2, they have nothing to pair up with, so they have to stay under the radical. All right, 18 is the same as 9 times 2. 9 is 3 times 3. Again, I have a pair of identical 3's. That tells me a 3 can come outside the radical. So what we have is the 3 that was already outside the radical. We have this other 3 that we can bring outside the radical. And then underneath the radical, we're left with that 2 and the x. So this 2 has to stay under the radical, and this x has to stay under the radical. Now you can see that we do have like radicals. So the like radical portion is the square root of 2x. So we're going to treat that square root of 2x kind of like a variable, okay? So let's see. We've got to do a little simplifying outside the radical expressions. 11 times 2 is 22. So we get 22 square roots of 2x. 3 times 3 is 9, so we get 9 square roots of 2x. So now I have 22 plus 9 square roots of 2x. So I have 31 square roots of 2x, and that's my final answer. So that is adding and subtracting radicals. We're not going to go any deeper than anything you've seen on this screen. The main focus is just knowing that you can combine radical expressions with addition and subtraction as long as the radical parts match, okay?